Well, today I started on the rockers that go in the four-way tool post on the little 10-inch Atlas production lathe. We're here at the little Atlas 7-inch shaper. Got shaper vise set up. I've rotated it to 30 degrees. And what I'm doing is just taking a facing cut off the top. Now I've got two pieces of 1/4-inch square stock, which is what I'm starting with for those rockers. And I've just set them up so they're basically parallel. I'm making a facing cut across the top. And once we make that facing cut, we'll drop our depth a little bit, change tools out in it to a little more pointed tool. This is just a standard roughing tool here, or a standard planing tool, whatever you want to call it. We'll change tool bits out of that, cut our cross hatch in here, and then we'll manually feed it across. I'm going to run it on power cross feed, traversing it right now to make the top cuts, and that'll give us our smooth finish, and we'll be even on top there. I haven't cleaned the mill scale or anything off the other three sides of this. It's not necessary to. They'll all get machined. Once I get these faced off and the crosshatch cut on the top, like I say, we'll do our 30-degree cuts this way. We'll rotate the vise the other way and repeat it and manually feed that across. Once we've got that done, we'll cut these in half because I made them long enough to get two out of each piece. And we'll cut them in half, set them on the rotary table, and cut the radius on the bottom of them so that they look similar to this with that radius. Then we'll go back and just chamfer the edges so they've got a little bit of a bevel. This one's quite rounded. The other ones that I've got an example of aren't quite this rounded. They are tapered down the sides, going, let's see if I can get it here oriented the right way so you can see it. It's tapered down on both sides a little bit, and then the bottom is just radiused a little bit. Nothing super precision there, so let's go ahead. We'll just start the shaper running. I'm going to go ahead and let it run in real time. I'm not even going to speed it up through the video. You can watch it. If not, why, you can fast forward, and I'll try and remember and put a marker in it so that you can skip this and go on to the next part if you so desire. Anyway, here we go. That movement you see is not flexing the machine. It's setting on a roller base, so it's still somewhat mobile. So we're seeing the whole machine move a little bit as the movement we're seeing. Okay, that's not that's what I'd consider a roughing cut there. It looks relatively good for what we want. And there again, for what we're using it for, I think it looks fine. Let's see if we can get a little better look at the cut itself. Not super smooth, but that's okay. This is a cold roll steel. The hash mark you see here is where I started it again when we started this video. So anyway, we'll go ahead, come up with another tool bit, and we'll change that out, and then we'll start cutting our pattern in that. Alright, well, we've changed out our tool bit. We've got a little more of a pointed tool on this. I probably would have gotten a better finish had I run this the other way. Once I went back and looked at that tool bit that was set up in there, why it was actually set up to face off the other way. So we would have gotten a smoother cut, but there again, for this application, it doesn't matter. What I'm going to do is, I've already manually ran a couple of cuts here. I'm going to start it running, and then we're just going to manually feed it a turn at a time because I don't get a coarse enough feed with the power feed on it. I think we'll go just a little bit lower than that. Okay, that doesn't look too bad. I think we'll leave that depth right there where it's at now, and we'll go ahead and rotate the vise 30 degrees the other way, and we'll cut across it and do the same thing. I think we'll feed from the same side as we did before, just because that seems to be a little bit easier for me. I'm not going to change the depth of cut. I think we can get that all in one cut. Will work just fine, it looks like. That gives us a little bit of a view of that. That looks pretty good. What I'll do is I'll just take a stone and lightly knock the tops of those off, and I think I'll actually do that while it's still here in the shaper, just because I can. And then we'll pull it out of there, we'll cut it in half, and then we'll have to set up the rotary table to make our bottom radius cuts on it. Take these over to the air hose and blow them off. And the way I shimmed that up in the shaper is I just used a bigger tooling bit and a couple of shims of aluminum to get it up above the top of the vise. Another good reason for having extra tooling around. Let me blow those off real quick. Okay, there's our top surfaces for those. Those work real good. Now these are not tool steel, these are just mild steel. I can probably use them like this. I may go back and case harden them. That may be a interesting little project we can do to these. This is the fourth one. And these were, if you'll remember when we cut them on the shaper, these were two long pieces. I cut each of them in half. They were about a 4-inch long piece. So each rocker is approximately 2 inches long. Hopefully I gave it just enough extra to where it's the right length, although there again, not critical. So we've got the top already cut. I looked at several ways to do these, and they've got a 6-inch radius across the bottom of them, which actually looks just like this, is our radius across the bottom. And I always tend to look at simplicity in manufacturing this stuff, which is how I think Atlas probably looked at a lot of these things when they built this stuff. And when we compare with a 6-inch radius across the bottom of that, amazingly enough, that's what Atlas's rotary table is a 6-inch table. So I would say that no, these were not built on an Atlas rotary table. That would not be the most efficient production method to do it. But I could possibly see them taking a casting for a 6-inch top piece and using that to build a fixture to hold these pieces if they indeed manufactured them this way. I don't think they did. In looking at these and in looking at a used one that I had, and then looking at 4 used ones that I had, or 5 used ones, because I've got another tool post that had all of these rockers in it. It has more of a look of a forging, and I've compared it to the other ones that I've got in the other tool post, production tool post. So it looks to me like it was a forging. They probably had a stamping die. You know, whether they ran them one at a time with a forging, whether they were a long strip that they ran through a forging press and it knocked them off and sheared the edges. And then I think they were just touched up on a grinder of some sort, which could very easily have been done on something like an Atlas rotary table. They could have used that as a turntable and quickly ran them across. This particular one shows some markings on it that run up and down like this, and they're kind of rough. I just lightly polished those off just to see. So I'm not sure about this one. The other ones look like they are more a forged piece to start with, and part of them have just a little bit of a either belt sand or grinder marks on them, probably where they weren't exact when they came out of the forging dies, so they set them up in a fixture and quickly ran them around to verify the radius, because I see some markings and some edges that look like they were forged. So anyway, neither here nor there. What I came up with, and I looked at several different ways to shape the radiuses on the bottom of these. I looked at using an Atlas rotary table and setting them up on the mill. Kind of a precarious setup. There's not a whole lot of material to grab onto, and I don't think there would have been enough, would have had enough holding force to do that. Thought about mounting them to a faceplate and setting them up on the lathe. There again, you've got the same problem. But what I ended up and came up with, and we're back to simple is better. I took the 6-inch faceplate, which is actually 6 1/4 inches, off of my Sheldon, and drilled and tapped it for 2 1032 screws. So it looks just like that. Mounted up there right there. And then what I did, let's lower the camera down, is I took my belt sander and my welding tabletop right here just like this. Mount that right about there. So there we are. There we go. And we have our last rocker. That's all 4 of them. Now I'm going to actually set up another little fixture just for the bench grinder that will hold this at just a little bit of an angle so that I can bevel this edge along here. Just turn it around, do the other side. That'll just be a little wooden angle grinder or angle plate that just tips it in just a little bit. It'll be quick and easy, and I can run a little bit of a bevel on the edge, and then I'll just quickly run a radius on the edge by hand just right across the belt sander. And it was just that simple. You know, it takes me about 10 minutes to grind that radius. Actually, it didn't even take me 10 minutes. We probably got about 5 in that. And we'll take and spend a little bit of time. We'll bevel that edge and then radius, and then we'll be done with these. Now, these are not hardened. They're just mild steel. I could just blue them for the uses that they're going to get. They'll last indefinitely if I do that. As an exercise in futility, we may clean those up and case harden them, just because I haven't got to play with case hardening for a while, so we might do that and see what kind of results we can come out with for that. So anyway, quick and easy. I'll bring you back when we've got the other little fixture to at least show part of the beveling on those. And yes, I've got a few little markings on the edge of my faceplate, and now I've got 2 more holes in it. So before everybody's panties get in a knot, why faceplates, angle plates, things like that were considered disposable items when they were originally machining a lot of this stuff. You know, castings were cheap. They had a lot of castings floating around for different projects. So things like angle plates, face plates, you know, a lot of cast iron parts that went on your lathe, your milling machine, whatever, were considered consumables and were just adapted to whatever job was at hand. So if somebody's going to be upset because I've made holes in a faceplate or ground some marks in it or cut some slots or something, why, too bad. Anyway, we'll bring you back when we've got a little more to show you here. Tooling fixtures. This is high tech here. Looks like it'll be pretty good right there. A little bit of a bevel cut in. Let's go and cut one and see what it looks like. Okay, there we go. It's going to be close enough. I'll go ahead and cut the other 4, and then we'll break the edges on them. Alright, I know the bearings in the belt sander wore out. They started chattering here and jumping around yesterday. Anyway, we're going to hit these with the buffing wheel. But there's our radiuses. There's our beveled edges. And they're all 4 pretty close to being identical. So we're going to hit them with the buffer. And until we decide if we're actually going to case harden these or if we're just going to glue them up and leave them, why, this will be the end of that. So if you find these videos helpful and you haven't already, you might want to hit that subscribe button. If you hit the bell notification, you'll know when I put out a new video. And any comments or suggestions, leave them in the comment section for me below. And thanks for taking the time to watch.